This is CPM Precalculus, Chapter 2, number 73. So here we have Louis. Lou walks every day at lunch when he is working. So his name is Lou, not Louis. Sorry about that. All right. So the amazing thing about him is that he walks at a constant rate, right? So constant being it stays the same. His velocity is constant, all right? So he walks for 1 hour every day, and his velocity is 4 miles per hour. All right, let's go ahead and do this problem. Part A. A asks us to graph his lunchtime walk. All right. So let's go ahead and graph it. We have two axes. We have our x and our y axis, right? Let me draw a little better. All right. So every day he starts at time 0 and he walks for 1 hour, right? This is going to be my time axis. And he walks for 1 hour, so he starts at 0 and goes 1 hour. All right? And he travels at 4 miles per hour. So over here, I'm going to say this is velocity in miles per hour, right? And he travels at 4 miles per hour, right? So 4, I'm going to go ahead and graph his route right here. He travels right here at a constant speed, right? From 0 to 1. All right. So that's the graph. Shade the area between the curve f of x. So we're going to call our curve f of x. All right. And the x-axis over the appropriate domain. So let's go ahead and shade this in. Over the appropriate domain means we just drop these points, right? And shade in underneath. All right. So that's part A. That is a graph of Lou's walk every day. His velocity is 4 miles per hour for 1 hour, right? Time is in hours. Part B. Part B says, explain why the domain will only be from 0 and 1. So between 0 and 1. Why is this our domain, right? Our domain we know is starting at 0 and ending at 1. Well, why is this true? Because he only walks for 1 hour, right? Right? We don't go any more to the right or to the left. Starts at time equals to 0, stops at time is equal to 1. So that's why our domain, right, we're going to scan from left to right. It's only going to give us outputs between 0 and 1. All right. What is the range? The range, remember, is scanning from negative infinity to positive infinity in the vertical direction. So what is this range? Well, where do we first get our first output, right? So we're scanning from negative infinity. We say no, 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 until we get to here, right, at 4. Because if you look closely, it's just a horizontal like line segment from 0 to 4. The height, right, is 4 the whole time. We shaded in this area, but this area is not part of the graph. So it's no, 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 only yes at 1 point. So the range is just at this 1 point. Okay, so how do we write that? Well, we can go ahead and just say 1 point, right? It's where y is equal to what? The range is where y is equal to 4, right? If we want to use set notation, we can go ahead and say 4 like this, okay? Over here is brackets, and now we have braces. All right, part C. So we did A and B. Be careful, the range does not include down here because this is just the area underneath the curve. All right, so the curve only has that one y value at 4. So part C says the figure that is shaded on your graph should represent or resemble a rectangle. All right, it looks like a rectangle, right? 4 sides. All these are 90-degree angles. These sides are equivalent in length, and these sides are equivalent in length. All right. Using your analysis and units from each axis, find the resulting units when you find the area of the rectangle. Well, I know the area of a rectangle is base times height. If I'm just looking at the units, the base units over here is just hours. So that's going to be hours times the height, again, is velocity miles per hour. Right? So we multiply these, the hours cancel, and we're left with just miles. Right? So the units, when we find the area of the rectangle, are in miles. So part D, I think, yes, we are going to find the area of the shaded region. So I'm going to even write this like this. The area of our function between 0 and 1, right? And that's equal to, well, that's just the base. The base is, the distance between 0 and 1 is 1, so that's 1 hour. The height is 4 miles per hour, right? You multiply these, the 4 times the 1 is 4. The hours cancel and you get 4 miles. All right? So the area is 4 miles, and we're done with part D. All right? So this ends CPM Precalculus Chapter 2, number 73.